So, hello and welcome. This is Aurora with Supercharged Math. I am just going to focus on the calculation techniques and skills, the actual application pieces with all the labs and the projects and the activities and the games and the puzzles and the challenges. You got to go back to their website because that's all on there. So I am just going to cover 7 weeks worth of calculation things that we were focusing on. And also I'm going to answer your question. So do definitely subtracting, cover division, how do you subtract? Okay, yes, great, perfect. So put all of your requests in and let's get started. Okay, so I'm going to take you down to my desk. Before I do, say a little kid came up to you and said, "What are you studying?" And you said, "Decimals." And they're like, "What's a decimal?" What would you say? You tell me out loud, type it in the box right now. What would you say? What is a decimal? Remember, it's a little kid, so you can't get all geeky technical on him, okay, or her. So what would you say? What is a decimal? Okay, go ahead and tell me while I am getting myself over to the desk. Okay, so what is a decimal? All right, is this a decimal? No. There's a decimal point, it's invisible, it's hiding, you can't see it, but that's a whole number. How about that? Is that a decimal? Okay, good. So a decimal is a number with a whole part and a fraction. Now we really like decimals because they are based on 10. Do you remember before with fractions? Fractions could be anything, right? 3/8, 2/3, right? That denominator could be anything. With decimals, you always know what it is, and it's always a factor of 10. Watch this. Do you know how to say this out loud? 3, and when you get to the decimal point, you say and. 3 and 2/10. Okay, so 3.2 is 3 and 2/10. If I put a 1 out here, this is 3 and 21/100ths. 3 and 213 thousandths. Okay, so what am I saying? What I'm saying is, whoops, there you go. What I'm saying is 3.2 is this, and some people just say 3.2. You can also say 3 and 2/10. This is the decimal, this is the fraction. It's always based on 10. So if I say 4 and 53/100ths, we just write 4 is the whole number, and you just write 53 over 100. Okay, so this is 1 decimal place, so there's 1 0. 2 decimal places, 2 zeros. Should we do a bigger one? How about this one? 625. Okay, so there'd be a 0 here. You don't have to write 0. You could just write the fraction. How many zeros are on the bottom? 1, 2, 3. 1, 2, 3. And what's on the top? 6, 2, 5. Look at that. You're converting decimals to fractions. How hard is that? That's not too hard, is it? Okay, let's do one more. What about this one? 1 1/4. 1.25. Okay, so here's the whole number. 1. How many digits? 2. So there's 1, 2 zeros on the bottom. And you just write the 25 on top. 1 and 25/100ths. Okay. Can we reduce this one? You bet. How many times does 25 go into 100? How many quarters in a dollar for US money? Yeah, there's 4, right? So 25, if I divide the top by 25, here, I'll put the whole number first, okay? If I divide 25 by 25, I get a 1. 100 divided by 25 is 4. So we've just reduced the fraction. If you're still not sure how to do this, don't worry about that. This works just fine. Okay, how are we doing so far? We're doing pretty good? Okay, so let's take a look at one of the pages we had in the homework because they do a much better job drawing these very quickly than I do. All right, can we write these together? Look at this one. I got candy bars, 4 candy bars, but only 1 bite of that one. So we write it as 4 holes and 1, and this is 10. There are 10 possible squares, and you only ate 1. Okay, what's this one? How many holes? 2, and how many possibilities? Always 10 for decimals, okay? So how many are filled in? Half of 10 is 5. So what do we write? Do we just write 25? The 2 is the whole number, and 5/10. Okay, how about this one? Can you write this one? This has 1, 2, 3, 4, 5 on the top and 2 on the bottom shaded. So what would this one be? Can you just tell me out loud? The whole would be 1. Good. What about the bottom? Or the second one? Yeah, that's a 1.7. Ooh, what about this one? Look at all the candy bars this kid has. 1, 2, 3, 4, 5. We have 5 wholes, so 5 point. And then how many bits? 1, 2, 3, 4. So 5.4. Do you see how much easier decimals are? Because that denominator is always a factor of 10. So much easier to deal with. All right, and this one? This one's only missing one little chunk. So we call that 1, and then there's 9 out of 10, so that's 1.9. Okay, if you wanted to write the fraction, this would be 2 and 5 tenths. This is 1 and 7 tenths. This is 5 and 4 tenths. This is 1 and 9 tenths. See, they're so easy to write, and we like that. And because that's one reason that they also are very popular with the metric system, because that's also based on 10. All right, what if they're based on 100? What if instead of 10 chunks like we had here, 10, what if the grid is chopped up into bigger, into more pieces? Okay, so this one, look, we have 1, 2, 3. That's 3 is the whole number, and only 8. Oh, I'm sorry, only 8 out of the hundreds. Okay, because not a whole, each row is 10. And we have 0 complete rows, so there's no tenths, but there are 8 units of 100. So it's 3.08. Yeah, sometimes the O gets a little tricky. How about this one? This one's completely done. This one is only missing 1. So what do we write? So the whole is 1, then we put a dot, and then what's this? So 9 of the vertical rows are done, and 9 out of 10 of the last one are done. So this one's 1.99. All right, let's do like this one. Oh wait, here, let's do this one. It only has 1. So what do we write? It only has 1 tiny box. So what's this one? Yeah, a 0. Are there any rows, any columns done? Nope. So that's also a 0. And then we just have 1. I know, one cute little one. All right, let's see. Can you do this one for me? What's the whole number? This guy? Okay, and then what's this? Okay, well, let's count. 1, 2, 3, 4. 4 are complete. Wait, is it 4? Or did my pen bleed over? It did. 5. 5 are complete. And then it's 1, 2, 3, 4, 5. All right, so you kind of get the gist of what a decimal, what information is hiding inside of this decimal, yeah? Just notice how decimals are based on 10, 100. We could divide this up into 1,000. Yep, we do that in with microscopes, absolutely. So when we have a ruler, right, this goes from 1 to 1,000 millimeters, so that's 1,000. We take a meter and divide it up into 1,000 tiny little bits. They can be in a line, they could be in a grid, they could be bars of chocolate, they could be a lot of different things. As long as they're equal parts, then we can use a decimal. Okay, so let's take a look at how we actually do this. So one of the requests was, please help me add and subtract decimals. You bet. Here is a decimal, 3.2 plus 5.13. All right, how do we do this? Okay, so we're going to take the 3.2, and you always line up the decimals. So 1, 3 goes here, and 5 goes there. What are we left with? Okay, so now we have to add. Do you see how the 2 is kind of big, and you're not quite sure if it's over the 1 or the 3? This happens all the time with decimals. So you want to make sure when you write it, it's really clear who is in which lane. So you want to stay in your own lane. Okay? So 3 and nothing is 3. 1 plus 2 is 3. 5 plus 3 is 8. And the decimal drops down. Okay? This is probably where you're going to see most of the problem, is sloppy writing leads to errors with decimals. Okay, let's try another one. Let's try another one. Suppose I have a 1.26 and I want to subtract 0.4. How do I do that? Okay, can you set up the problem? Line up the decimals, just stack the numbers one on top of each other, and the decimals go right there. So you start with the decimal and you say, okay, on this side there's a 0, on that side there's a 4, and then there's nothing. And then don't forget your minus sign. All right, nothing from 6. It gives you 6. Okay, now put your hand here. Do you know what 4 minus 12 is? 4 minus 12. Did I say that backwards? I did. I did. Let me do that again. 12 minus 4. There, what's that? That's 8. There you go. 0.86. How are we doing? Yeah? Smile if this is kind of making sense. Yeah, so for adding and subtract, you have to line up that decimal point. If you don't, you're going to get the wrong answer, and then all that work you just did is totally wasted. Here, let's do another one. How about 1.3 minus 1.1? Okay, 1.3 minus, line up the decimal, 1.1. What do you get? So 1 from 3 is 2, decimal point. Uh-oh, is this a problem? Does this like explode my problem? No, we just put a 0. Okay, so it's 0.2. Okay, how about a harder one? How about 4.26 minus, or actually let's do plus, 13.1. Okay, let's do that. So 13.1, and then we put the decimal point down, and then you just expand the number on both sides. Do you see how if I had gone like this, 13.1 plus 4.26, I would get a totally different answer? Do you see that? Like this is like a 5, and this is a 5, and this is a 7, and I have no idea where the decimal point goes, right? Okay, so that is big fat no, don't do that. So line up the decimal point, and then you can start adding. And it's okay if there's nothing here. It's just treat it like a 0. So 6 and nothing is 6. 1 plus 2 is 3. Bring down your decimal point. 3 plus 4 is 7, and 1. This is a very different number than 557 with no decimal point. So this is the right one. Good. Okay, so let's move on to multiplying decimals. I think multiplying decimals is actually easier than adding and subtracting. So let me show you what I mean. If I have 2 decimal numbers, if I have 2 numbers, could you tell me what the answer to that is? Just off the top of your head. Do you know the answer to this? Okay, what is it? Just shout it out. Yeah, it's 84, right? Okay. It's not. Uh-oh. You sure? I'm pretty sure it's 84. Uh-oh. Let me see some more kids nodding. Is it really 84? It better be 84. Okay. So if I say this, does this look like that problem at all? Maybe not, because there's a 0. But you could put a 0 in front of the 7 and still be a 7, right? It's actually the same problem. So when you multiply decimals, when you first start out, you ignore the decimal points, and you just do the problem like you're used to, like up here, because you guys are all good at multiplying numbers. So I'm going to say it's equal to 84. But that's not quite right, because there's decimal points here. Okay, so what do we do? So remember before how I said this is a whole number, and there's a decimal point hiding out here whenever you need it. Okay, so now we need it. All right, so to get from 7 to 0.7, so 7 has a decimal point here, and so does the 12. Okay, so watch this. To get from here to here, we had to move the decimal point one direction this way, correct? Right? It just went 1 over. Okay? So we also have to do that here. We have to adjust our answer. Okay, now let's do it over here. To get from 12 to 1.2, we had to move it one direction this way also. So now we go again. Because there's 2 hops, one for each decimal place, my answer is, watch. Can you see my calculator? Yes. No. There we go. 1.2 times 0.7. What's my answer? 0.84. Okay. So I want you to treat it like just a regular, so initially leave the decimal points off and then just adjust your answer. That's probably the trickiest part to this whole thing. So if I were to say 3 times 11, what would you say? 3 times 11 is easy, right? 11s are always easy, 33. If I were to say 0.03 times 1.1, what would you say? You'd say, help, Aurora. Okay, great. So I'd say, all right, we'll rewrite the problem. So this is really a 3 And this is a 1 point, this is an 11. So 3 times 11 is, so just write the answer down, 33. Okay, now let's adjust our answer. The biggest problem with multiplying with decimals is figuring out where does that pesky little dot go. So how did we get from 11 to here? There's a decimal point here on the end of each of these numbers. Okay, it's there if you need it. So we need it to go 1 hop this way. Okay, so we did 1 hop. Okay, so the 33 has a decimal point, it's right there. It's always at the end of the whole number. So we're gonna do 1 hop. Okay, now we're gonna look here. How many hops did this one do? Okay, it went 1, but then there's a 0 here, right? So it went 1, 2, and then wound up right there. Okay, so what does that mean? That means I need to do 2 more. 1, 2. And even though there's nothing there, my placeholder is a 0. So 0.03 times 1.1 is equal to 0.033. That's my answer. How is this kind of making sense, how to do this? Yeah, figuring out where the decimal point go is the name of the game, and that's all you have to do with this one. So you want to reduce it to a problem that you can easily do. All right, so what if I tell you 103 times 692 is equal to 71276? Okay, I just tell you that. All right, now I tell you I want to know 1.03 times 6.92. Can you tell me the answer without doing any multiplication in your head? Okay, write in the answer. I'll give you about 10 seconds. Go ahead. Where does that pesky little decimal point go? Okay, the decimal point is right here, here, and here. Okay. What do you think? What do you think? Okay, so what did we do? How did we get from 103 to 1.03? We went 1, 2 hops, okay? How about this one? We also went 1, 2 hops. Okay, so that means this goes 1, 2, 3, 4. Did you get 7.1276? Okay. And also you can ballpark it. This is about 1, right? 1.03, that's about a 1. 6.92, that's about 7. What's 1 times 7? It's about 7. So that's another way to check your answer to make sure that you're getting the right one. You want to try one more? Want to try one more? Okay. So you guys give me a couple of 3-digit numbers. Type them in right now really quick. Just give me a 3-digit number and I'll just grab 2 of them. Okay, go ahead. I'll get a fresh sheet of paper while you're typing. All right, I have 236 times 567. Okay. All right, so here, 236 times 567 is equal to 133812. Okay, so there's our number. I'm going to adjust this problem. 2.36 times 0.567. You tell me the answer. What's the answer? All right, did you get it? Okay, there's a decimal point. You want to know where the decimal point is. It's always at the end of the number. Always at the end of the whole number. Okay. We did 2 hops here. 1, 2. It's right there. And we did 1, 2, 3 hops to get here. So we go 2, 1, 2, and 3 more. 1, 2, 3. So our number should be 1.33812. If this is starting to make sense, let me see a smile. Let me see a smile if this is starting to make sense. Yay! Especially if I'm sitting here doing it with you, right? Totally makes sense. Yes, of course. Yay! All right, stand up just for a quick stretch, stretch, and then sit back down really quick. All right, stretch. I know. You guys are sitting for too long. Stretch. Okay. We are going to take a quick stretch break here just for a second. I'm going to get some water. You're going to tell me what else do you want me to talk about. I already have dividing decimals is next, but you tell me what else would you like to study? What else about decimals can I answer? We have about 15 minutes left. So we have dividing decimals. So the if you're looking for the, I'm trying to say three things at once. If you're looking for the labs, then you want to go back to the decimal page. We're just doing calculation because we have such a short time, and I'm covering 14 sessions in one 30-minute session. So we're just doing calculation just right now. So square root of a number, that's a good question. Can you save that? Because that's going to be something we're going to handle, squares and cubes, when we do algebra. Okay, subtracting. We actually just did subtracting. If there's something specific you want to know, I'm happy to do a problem as well. If you can give me a sample problem, David, that would be great. Okay, let's go back to the desk and let's talk about division. All right, dividing decimals doesn't have to be scary. Doesn't have to be scary. For example, if I have, I'm just going to give you the problem in the box. Okay, if I have this, could you do that? Yeah, there's no decimals, right? Could you do that really quick? 2 goes into 3, how many times? 2 goes into 3 once. 1 times 2 is 2, minus a 2, carry the 1. Bring the 6 down. 2 goes into 16, 18. We have no remainder. Yeah, you're pretty happy with that, right? That's a pretty easy problem. Okay. What if this is 2 divided by 2, so 3.6 divided by 2? What happens now? How does my problem change? The only thing that changes is you push the decimal point up. And that's it. It's the same thing. There's no difference. Here, let's do another one. Let's do another one. If I say 96 is in the box, the 3 is outside the box. Can we do this one together? No decimal point. Okay, 3 goes into 9 how many times? 3 times something equals 9, right? 3 times 3. Here, I'll do it in a different color that's a little bit more visible. 3 times 3. Okay, gives you 9. So we have nothing left over. So drop the 6. 3 times something gives you 6. 3 times 2, and we have no remainder. Okay. So if this problem was like this, you would just push it up, and that's the answer to the problem. So that's the only difference. Yeah. Oh, you mean dividing. Okay, that's great. Okay, so that's the only difference between these dividing regular numbers. So if you're good at, if you know how to do these types of problems in black, then just adding that little blue decimal point, you just push it up. Okay, so let's talk about a few more examples that are probably more complicated than that. Okay, so if I have, let's see, I'm going to use one of your numbers you gave me before, 236 divided by 2, okay? So 2 goes into 2 how many times? 1, right? Minus 2, 0. Bring down the 3. 2 goes into 3 how many times? 1. 1 times 2 minus 2. We have a 1 and a 6. Here, let me back up the camera a little bit. Okay. All right. 16. 2 goes into 16, right? Is this looking like something you probably learned years ago? Yes? Okay. So if the number is this, if my decimal point is there, what am I saying? I'm saying 23.6 divided by 2 equals 11.8. Because all we're doing is we're pushing up this decimal point right up there. Okay? So that's how you handle it. So if the decimal point is throwing you, get rid of it. And just like we did with multiplication, then just put it back in and adjust your answer. And you can see like 23 is close to 22 divided by 2. 22 divided by 2 is about 11. So you can always check your answer to make sure you put it back in right. Okay, so let's take a look at when the problems are harder. Okay, so if I give you a problem like this, okay, so everybody repeat after me. Yuck. All right. How many people have problems like this and you're like, okay, I give up. That's it. I can't do this. You can't. No, you can totally do this. Watch. All right. I don't know my 1.2 times tables. I don't know about you, not one that I memorized. So what I'm going to do is I'm going to adjust this problem. I am going to move that over because I do know my 12s times table. So if I move this over one, I also have to move this over one. Okay, so let's rewrite the problem so it's clear. So 12 into 96.13. 2. This I can do. This one, I don't know this. If this was a 1.3 or a 0.8, I don't know that. So you can move the decimal point, but if you do that, you'll change the problem unless you also change it in here. Okay, so you got to do it in both places. Okay, so 12 doesn't go into 9, right? We don't have enough cookies for 12 hungry kids. If we have 96 cookies, though, how many does everybody get? Does everybody get 8 cookies? Would you agree? Would that be 8 cookies? Okay, so everybody gets 8. Minus 96 is a 0. Okay, so I have a 1, but nothing happens there. So I put a 0 here because 12 doesn't go into 1. 1 cookie and 12 kids. Can you imagine? All right, that better be one big cookie. So bring the 12 down. 12 goes into 12 one time. Question, where does my decimal point go? All you do is you push it up, and it goes right there because the 8 is right over the 6. So when you do these, just make sure that everything stays really lined up. And if you're kind of a messy writer, you can use grid paper or even just draw lines down the page just to make sure everybody's in their own lane. Okay, let's do another one. How about this one? I do not know my 0.04 times table, but I do know numbers. All right, so let's do this one. Okay, so we're going to adjust the problem. So can you rewrite the problem on your page? Okay, so adjust it. So what do we need to do here? How do we adjust it? Look up here if you need to. Rewrite this problem on your page. Okay, and I'm actually going to do it on a different page. So I'm going to do it down here. Okay. Oops, look at me doing the wrong thing. Hang on. Okay. Did you get this? Is that right? Okay. So what did we do? We went 1, 2, and we put it right there. Because we did 2 hops in this direction, so we better do 2 hops in that direction. Okay? So 4 doesn't go into 2. 4 goes into 27. How many times? 4 goes into 27, 6. 6 times 4 is 24. Okay? And we have a 3 left over. Drop the 5. 4 goes into 35. Yeah, it goes in a little bit, right? What does it go into? Okay, how many times does 4 without going over? Somebody said 9. That's too many. How about 8? Yeah, what's 4 times 8? 32? Okay, great. And we have a 3, and then here's another 2. Yeah, and we can do that same number again, right? Because it's exactly a match. Okay. Where does the decimal point go? The decimal point just gets pushed up, and it goes right there. So if the decimal point is throwing you, just ignore it and just do the numbers, and then put it back in until you're comfortable. Somebody's asking, what if this had been like a 3? Okay, good question. If that had been a 3, then I would still have an 8, but I would have a 1 left over now. So, and then I have as many zeros as I want. Oh, wait, I'm sorry, you can't see that. Then I have as many zeros as I want right here. And so I can drop that 0 down to make a 10. 4 goes into 10 2 times, and that's minus 8. Now I have a 2, and then I drop the next 0 down, and that's a 20. And that goes in evenly. So you can add as many zeros as you want. The decimal point doesn't move, it stays there. And you just keep getting more and more digits past the decimal point. Yeah. Okay, so how are we feeling now? How are we feeling? So that was actually most of what I wanted to talk about, and we finished a little early, which means, do you guys get a longer story? Okay. All right. So other questions. Can you show how to multiply fractions and decimals if it's possible? Yeah, that's actually a good question. Let me do that. And then let me answer a couple of your questions, and then I have a story for you. Okay. So how do you do a fraction and a decimal? That is something we're actually dealing with right now. So this is perfect. So can you give me a decimal number? Can you guys type one in real quick? Give me just make it like a 2-digit one. 2-digit past the decimal point. I'll come up with a fraction. So let's say it's 3/8 times, what do you have? 9.45. There you go. Yuck, right? Okay, so how do you deal with this? So I would convert this to a decimal, okay? Because this is an odd one. So you have two ways. Way number one is way number one is writing the correct thing. 3 over 8 times 9 and 45 hundredths. So you could do it that way. That's with fractions. And then you would turn this into an improper fraction. So this would be 3 over 8 times 9 times 100 is 900 plus 45 is 945 over 100. Do you see how this is getting really big? Yeah. So I wouldn't necessarily do it this way. I would say this is a division problem. Okay? So I would say what's 3 divided by 8 in decimals? Now I know that just because I've been used to it, but if you don't, you just say 3 divided by 8 is 0.375. Okay? And now you just rewrite the problem. So I have a 9.45 times a 0.375. And that's the problem that you do. So you have to convert one to the other. This one feels more cumbersome. Sometimes this might work better. So this one, does this make you feel a little nervous though? Okay, so I might rewrite this one to be 945 times 375. Okay, and then we can do this. Oh, I know what I'm going to do. Whoa, wait, hang on. Let's do this one. So 945 times 375. I'm going to give you the answer. You tell me where the decimal point goes. 354,375. I did all the hard work. Remember, calculator did. Where's the decimal point go? So where does that decimal point go? All right. So to get from, the decimal point is here on both of them, or all three of them. Okay. How did we get from here to here? What did we do? We went 1, 2, okay? And what about this one? How do we get from here to here? So it started at the end and it went 1, 2, 3. So what's the answer? Where does that decimal point go? So I had 2 hops here, 3 hops here. 1, 2, and then 1, 2, 3. So my answer is 3.54375. This is probably the most important part of this whole decimal lesson, figuring this part out, because you guys already know how to multiply numbers. That part doesn't bother me, but I do want to make sure that you're aware of how to figure this out and also how to ballpark your answer. This is 9 times 0.375, which is real close to a third. So 9 times a third is the same as saying 9 divided by 3 is about 3. All right, good question. I think that was from Violet. Good question, Violet. Okay, and if it wasn't from Violet, well, thank you whoever asked the question. Okay, other questions? I can't write fast enough. Oh, I can leave it up. Would that help? Here, there you go. There you go. All right, good. And if you are new to the program looks like this. It's an online self-paced program, which means you go through the program at your own pace, on your own schedule. So we had started in September with fractions, and I had taught 7 classes, so 2 classes a week, myself and Doug. And so there are 14 sessions, live sessions that are recorded in fractions. And now, after that, we were done with that, we went into decimals. And not only did we cover just how to handle decimals, we spent a lot of time in practical application and also what decimals mean. So we also spent time in place value, and we had some bonus labs. There was 2 labs, I think, in geography as well in this unit. And so we also covered the metric system. So we had a lot to do in 14 sessions. And so if this is an area where you're still struggling with decimals, you don't understand it, you don't get it, this might be a good class for you to participate in today. So I am publishing between 16 and 25 videos every week. And so that's a lot of content.